Hello and welcome to FourthBrain. I am Sohini Roy Chowdhury, the Curriculum Director, and I have been putting together the course structure for FourthBrain. This week, I wanted to give you a sneak peek of the updates that I have been making. Today's topic, regression models. Let's get straight to it. So today's topic is regression models. Let's see what it entails. So regression problem is a statistical process which entails in order to find the relationship between a dependent variable, which is typically represented by y, in terms of other independent variables, which typically is represented by x. And if you are looking for some of the data in order to play around with it, so you can actually look for the UCI ML repository, and if you go for the regression class of models, you will see a lot of data sets that have been submitted that cater to specifically the regression problem. Some examples of this would be predicting housing prices. So what's the price of a house based off of the area that you know, and that would be your independent variables. In this case would be the area, the region, the school district and everything. Those become your independent variables in this case. For automotive sales, again, it's the cost of a car, or you can also be estimating how many cars would sell in a particular region if you know the make, model, and you know the build of a particular car. Or it could be problems like what is the credit risk that a particular individual poses, given that these are the different accounts that the person has, these are the different mortgages, and this is how much you make a month, and so on and so forth. So these are categories of regression problem. In order to find solutions for regression problems, there are very iterative ways of doing that. One of them, which is a very well-known solution, is the gradient descent, is where you estimate the location of the global minima in a very iterative fashion, like the left diagram shows. Or there is another method which is called the normal equations, in which you don't iterate through the solutions, but you actually find the optimal solution in one shot. So now I wanted to look at what regression models are not, or where should regression models not be applied. First of all, it should not be applied in problems that have a more of a time series component to it. One example of it is, let's say that in the present times, if you're trying to predict the number of infected people on a daily level with COVID-19, or if you're trying to predict the number of hospital beds that are going to be occupied on a daily level. Here you see that the outcome of every passing day actually depends on the day before and the day before and the day before. So there is a time series impact on the outcomes, because of which a regression model fitting on such problems will give you a very myopic view of the patterns and trends, and it will not be able to capture the increasing and the decreasing patterns of the overall data. The other case where regression should not be applied is heteroscedastic data, and that is where the variance between this dependent variable and the estimator is not fixed, but it changes with respect to the population. And the last piece where regression models should never be applied is if the data is not independent and identically distributed, or IID. Now let's look at some examples of regression predictions. Let's take this sample problem where you are trying to predict what are going to be the relative trends of sales for cosmetics at a local drugstore. So let's say you identify every single cosmetic product by a product ID that can be, from starting from 1 up through 75, and of course you have some features defining each and every product. It could be the brand, it could be the color, make, as well as the price. And then what you're trying to predict is the probability of sale. So in this case, your Y becomes probability of sale, and the different kind of regression models that we can use at hand would be decision trees, or GLM, or generalized linear models. And the black dotted line is the ground truth. It is showing you how the trends, in some cases the regression models can actually be off, and that is because your training data set might have a different distribution from your test data set. Now let's look at some examples of regression models. First of all, let's look at the generalized linear models, or GLM. The GLM typically consists of 3 different components. First of all, there's a random, then there's a systematic, and finally there's a link function. The random component actually identifies the distribution of the Y variable, or the dependent variable at hand. Based off of the previous example, this would be the probability of sales for cosmetics. The systematic component identifies the set of independent variables. In the previous example, it was against the color, the brand, or even the price of the cosmetic that we were looking at. And finally, we need a link function, which could be identity, it could be log, or it could be logistic, in which case it identifies a function for the mean of the data points. That is a linear function in terms of these explanatory independent variables, which are my x's. Next classification model is classification and regression trees, or CART. Now let's look at an example of how decision trees work. Let's say that you have this whole space populated where you have your dependent variable y in terms of independent variables x, and what you're trying to do is, based off of certain patterns that you see in the data, you actually divide this whole region into subspaces, and every single subspace would now entail a different decision point for this decision tree. Now let's say that you're looking at this sample which corresponds to this area 1, and then you would see that this tree actually will tell you how to get to region 1 based off of blocks which is at region x1 and y1, and you will essentially form such decision trees for classification as well as for regression functionalities separately. And this is a very strong tool to actually give you predictions, even if you have a new cosmetic or even if you have a new product that is going to be launched in the test data based off of its similarities to the existing training sample. Thanks for watching, and next week let's stay tuned for classification. Thank you. Goodbye.